Hi, welcome back. We're up to Lecture 3, Segment 2. And in this segment, we're going to talk about distributions, and we'll look at distributions in graphs called histograms. So a histogram is one of the simplest graphs that we use in statistics, but they're very useful and very informative. So it's just a type of graph used to display a distribution. So you might think, why start with histograms? There are lots of fancier graphics that we can start with. But a histogram is nice because it helps us to overcome our sort of natural tendency to rely on summary statistics. And this is just a natural thing. As an analogy, think of just stereotyping. It's very easy to stereotype individuals who are part of a group because you can rely on your sort of summary statistics of that group to make an inference about an individual. But as we know, we shouldn't do that if we want to get to know individuals within a group. We want to look at the entire distribution. We want to look at everybody within the group before we calculate those summary statistics or jump to those conclusions, those summary conclusions about a group. So here's a quick example of a nice normal distribution plotted in a histogram. So we're going to look at a lot of histograms in this segment and throughout the course. They'll always take on the same form. So on the x-axis, I'm plotting whatever variable it is that I'm looking at. In this case, the example is body temperature measured in degrees Fahrenheit. And on the y-axis, all I have is frequency. It's just the number of people in this distribution, in this sample, that have this particular body temperature. So in a second I'll do this in Celsius because I know we have an international audience, but in Fahrenheit, normal body temperature is about 98.6 degrees. That's what most people go with. So if you look, where 98.6 degrees is right about here. So yeah, it's right about the average. This group runs a little hot, you might say. So that's a nice normal distribution. A characteristic of a normal distribution is if I wanted to sort of smooth this, I could draw a curve over it. It has this nice bell-shaped curve to it. And the way to spot a normal distribution is to look for that signature bell-shaped curve, and it's symmetrical around the mean or around the average. So you can see there's just the number of cases beyond the mean is about equal to the number of cases below the mean. So it's symmetrical and has this nice normal bell-shaped curve. Here's the same exact data, just plotted in terms of Celsius. So now on the x-axis, you see we're just plotting temperature measured in degrees Celsius. Again, it's a normal distribution. We did these graphics in R, and you've seen R a little bit in the labs. And R just bins these differently, so you can see the width of these bins are different. And again, you can set that, if you remember using the R function hist and the argument breaks, you can change that if you like. But this is just the same exact data plotted in Celsius instead of in Fahrenheit. So those are nice normal distributions. But histograms can reveal a lot of information that's not captured by summary statistics. So just for an example, let's run with this body temperature example. Assume a few kids in the class are sick, just a couple. They have the flu, for example, and they have a really high body temperature. We might not capture that just by getting, say, the average body temperature across the whole group, especially if it's a really large group, right? Those couple of kids who are sick won't really show up. But if we look at the histogram, then what we'll see is we have, like, here's one kid out here who has a temperature of like over 101. Okay, I actually had a temperature of 101 last week. Didn't feel good. Delayed the start of Statistics 1 this year. It was nasty. So here's this kid who has this one kid in the distribution. So it's not quite normal. It's more like this, right? If I had to smooth it out. So that's what's called a skewed distribution. And this is a positive skew. And the way to remember that is the skew is where there's few. So there are fewer scores at the positive or high end of this distribution. That's why it's a positive skew. Okay, so the skew is where there's few. This is a positively skewed distribution. This is the same exact graphic, just presented again in Celsius instead of in Fahrenheit. And again, we don't get a nice normal distribution. We get something that looks more like that. It's not quite as skewed as I drew before, but you get the point. It's a little bit positively skewed. Now, again, not all distributions are normal. We're going to assume normal distributions for a lot of the statistical procedures that we do in this course. But we need to examine that first. So a first step in a lot of our labs and a lot of the homework assignments will be to plot histograms and determine if we have normal distributions. But there are lots of distributions that are not normal. So let's look at a couple that are not normal. So again, I'm going to run with this body temperature example for a few more slides and say we have one group of children, the entire group had the flu. Say a whole classroom full of children got sick with the flu. And then they were treated, they were given, say, antibiotics, as I was last week. Thank goodness for the antibiotics. And one thing that can happen with antibiotics is it can actually suppress your body temperature a bit. So after getting the antibiotics, that group of children, their body temperatures might be a little bit below average relative to normal. And then let's compare them to a second group, a second classroom of kids who also got infected with the flu, but maybe say a week later. So their body temperatures are still high. Okay, let's look at that in graphics. Again, I'm going to do this first in Fahrenheit, then in Celsius. So here's, on the left, a normal distribution. It's pretty normal. But it's a little bit below average. Remember I said the average is 98.6. And in this case, we're actually a little bit below 98, it looks like, is the average for that group. And here, again, we've got a pretty normal, not perfectly normal, but pretty normal distribution. And this group is a little bit above average. So we've got the average looks like it's approaching 100. So this is the group of children who are still sick. They haven't had the antibiotics yet. Imagine that I didn't know that these were two separate classrooms of children. Imagine I just looked at their body temperatures and plotted the histogram, all of them together. So let's put them together. So if we put those two distributions together, the group of children who are on the antibiotics and their body temperature is a little bit below average, with the group of children who are still sick and haven't received the antibiotics, their body temperature is still above normal. What you'll see is a distribution that looks like this. It's actually bimodal, meaning it has two modes. So if you look at it carefully, you can see there's sort of a normal distribution there and a normal distribution there. It's the two distributions put together. So if you didn't know that, it might be hard to see, but the more practice you get at looking at histograms, the more you'll start to see these evidence of non-normal distributions. So this is an example of something that looks not normal. Instead, I would describe this as bimodal. Again, I'm just doing the same exact thing, except here I'm plotting everything in degrees Celsius instead of degrees Fahrenheit. So here, this group is a little, if you look at the average, they're a little below average. If you look at the average for this group on the right, they're a little above average. If we put them together, again, what we see is something that looks a little bimodal. You get these two peaks. There's a peak here and a peak here. Remember, in a normal distribution, there's just one peak right at the center of the distribution. Here, we're seeing two peaks, and again, it's evidence that we have these two different samples of children that were put together. So the point of that exercise and the point of looking at all those histograms is to just make this simple point that not all distributions are normal. Yes, we are going to assume a lot of normal distributions as we go forward in this course. It's easy, especially for introductory statistics, to assume a normal distribution. But we'll make that assumption, then we'll test it by looking at histograms, by running descriptive statistics in R. We'll see if we have normal distributions or not. So we'll assume normal distributions, but just keep in mind, not all distributions are normal. So simply viewing a histogram often reveals whether it's not normal. You might have a positive skew, you might have a negative skew, you might have something that's bimodal, you might have something that looks completely out of whack, not normal at all. Sometimes it's hard to determine just by looking at the histogram, and it's a judgment call. There are no hard and fast rules about this. So in that case, summary statistics will help, and we'll talk more about that in the next lecture on summary statistics. So the only way to really get a good handle on what does a normal distribution look like and what does a non-normal distribution look like is just to look at more and more histograms. The more experience you get with this, the more you'll be able to say, yeah, that's normal enough for our statistical procedure. We'll go ahead. Or that's too positively skewed, that's too negatively skewed. So the best way to do that is just get experience. So let's look at more distributions. This can get a little tedious, so while we do it, we'll imagine that we're wine tasting. Or you're at home, you could start drinking wine right now if you haven't already. I haven't yet, it's still in the morning here in the US on the East Coast. So let's go wine tasting. So in this example, suppose that we have 100 wine experts, and they're going to drink and rate the overall quality of 8 different wines. They're going to rate 4 red wines and 4 white wines. And in all the examples, higher scores indicate higher quality. So if they give it a score in the 90s, that means they really liked it. And let's say we had 4 countries submit 2 wines each. So I just picked 4 countries. I actually picked 4 countries where I know we have a lot of Coursera students in Statistics 1 in these 4 countries. So it wasn't completely random. These are 4 countries where we have a lot of students and they're known for producing lots of good wine. So Argentina, Australia, France, and the US. Each one submitted a red and each one submitted a white. We, again, just did this for fun. My assistant on this is from France, and so we had a lot of fun doing this example. So let's say Argentina submitted a Malbec. They're very known for their quality Malbecs, and a Chardonnay. Australia, let's say they submitted a Shiraz and a Pinot Grigio. France, let's say they submitted a Bordeaux and Sauvignon Blanc. And the US, let's say they submitted a Cabernet and a Riesling. And you may say, Riesling from the US? But yes, upstate New York has really great Rieslings, which is where I'm from. So that wasn't random. I had to slip that in. That was personal. So the US submitted a Cabernet, probably from California, a Riesling from upstate New York, let's say. Okay, to preview what we did, again, we just made up this example. We had a lot of fun making this example up. And we made it up so that the red wines, the distributions of the ratings are normal in the red wines. But if you look at the ratings of the white wines, those are all not normal. So here are the distributions. We just simulated data in R. It's very easy to do. We'll show you how to do that in a later lab. And then we plotted them in histograms. So again, what I'm looking at here on the x-axis is just the wine rating. And then on the y-axis, how many wine experts gave it that particular rating. So you can see for the Argentinian red, that's the Malbec. They had a nice normal distribution. The Australian red was the Shiraz, I believe, right? That's a really nice normal distribution. Can't get much more normal than that. Let's look at the distributions for the French red and the US red. The French, not completely normal. There's a little bit of a skew down there, but it's pretty normal. And the US, again, nice normal distribution. Let's compare that to some non-normal distributions. So now let's look at the white wine, the ratings for the white wines. First, if we look at the ratings from on the Argentinian white wine, you see you get this one big peak right in the middle, right? So most of the wine experts just found this to be a pretty good wine. The rating is around 70 to 72, so they found it above average, but most of them rated it right in that category. So it's very, very consistent, right? In contrast to the Australian white, here you see you're getting a little bit of that positive skew. So this one's not looking as normal as the red wine distributions. There's a positive skew in this one. Now let's look at France. France is sort of, their distribution is sort of the opposite of Argentina, right? Instead of having one big steep peak, there's what we call a uniform distribution. That is, the ratings were all over the place. So some of the raters loved it, some of the raters hated it. Okay, and then the United States white, that was the Riesling. This has a bit of a negative skew to it. Again, the skew is where there's few. So there's very few ratings right down here at the low end. So very few of the wine raters gave that US white wine, the Riesling, a really low rating. So it's a little bit negatively skewed. So all of those are just to show you that there, in many cases, like body temperature, like the wine ratings for the red wine, we're going to get these nice normal distributions. And in a lot of cases in the labs, in the homeworks, we're going to deal with variables that give us nice normal distributions. But we can't always assume that to be true. So we're going to have to look and see if there are non-normal distributions lurking in our data. So to summarize this segment, we use histograms to display an entire distribution because they sometimes reveal information that summary statistics gloss over or won't tell us. And many, if not most, distributions that we deal with are going to be normal, but some distributions are not normal. And for example, we looked at the bimodal distribution with the two classrooms of kids who were sick, the ones who were treated and not treated. We looked at positively skewed distributions, negatively skewed. We looked at uniform distributions. So that was like the white wine distribution in France. That's uniform, or another phrase for that is platykurtic. And the last type that we looked at was leptokurtic. That was like the white wine distribution in Argentina with that one steep peak, is also called a leptokurtic distribution. And now I just wanted to show you a couple of advanced visuals or advanced histograms. And if we could zoom in on these, if you could zoom in on the top and then the bottom. Since we talked about longitude and latitude and we've talked about histograms, I wanted to show just these two very cool graphics that I just picked off the internet. And what this shows is the world population as a function of latitude and as a function of longitude. So if you look at the top graph, what we're plotting is you get this like nice normal distribution pretty much, right? What that means is most people live around the equator, and as you move away from the equator, fewer and fewer people live in those places. The same can't be said about longitude, right? So if we look at the bottom graph, we don't get a nice normal distribution. Instead, we get like a peak here, a peak here. What are those peaks? Well, here this peak is probably China. This peak reflects the population in India, right? So where you have a normal distribution of population around latitude centered around the equator, the same can't be said for longitude. The distribution is not normal. The population distribution is not normal across longitude. Just one more example of sort of advanced graphics that you can do. There's lots of these available on the internet. This one is right on Coursera's homepage. So if you want to know more about where Coursera students are logging in from and where their country of origin is, you can look at this graphic by Coursera. And what Coursera did is they just plotted around the globe. They colored different countries, and the darker the color given to a country reflects more students, more Coursera students from that country. So you can see we have a lot of students from China, we have a lot of students from India, a lot of students from Australia, and so on. These little circles refer to institutions that are partners with Coursera. So this is a fun graphic. It's actually interactive on the homepage on Coursera. You can play with it. So here we are in Asia. I can move around the globe, and there you see Europe is very well represented. Some parts of Africa are represented, but we have a ways to go, I would say. Then if I keep moving around the globe to the west, keep moving around the globe to the west. Here's the U.S. Of course, lots of partner institutions. Those are all the circles in the U.S. So lots of students from the U.S., lots of students from Canada, lots of students from Brazil as well in South America. And again, that's available on the Coursera webpage if you want to look at that. It's just an example of sort of putting distributions into advanced graphics, and there are lots of other examples you might run into on the internet or in the news that do similar things. So that's the end of this segment.